Today my topic is Baeyer strain theory. So I would like to teach you what it's the strain theory is all about. So strain means just initiate the observations by observing the bone angle from the normal tetrahedral value. If it is having the same, so if it is having the change in the bone angle, it is deviated, deviated, which will be considered as the internal strain on the ring, and it can lead to breakup of the ring. So if it is having the higher value, then it will be having the less of energy, higher of energy and a highly unstable compound. The bone angle is almost in 109.28, or it will be called as 109.5 degree. Any carbon compounds always likes to be in tetrahedral geometry, which is the most stable form of it. So Baeyer observes that the different bone angles for different cycloalkanes and observe the different properties, stability, reactions, etc. So on the basis of these, he said one particular theory which is called as angle strain theory. Okay, angle strain theory. It is all about the angles. So here is the angle strain theory. So angle strain theory is all about the Baeyer strain theory. The theory explains the reactivity, stability of the cycloalkanes. So Baeyer proposed that optimum overlap of atomic orbitals can be achieved at an angle of 109.5 degree. In short, it is the ideal bone angle for all the alkane compounds, that is 109.5 degree. Effective and optimum overlap of atomic orbitals produce maximum bone strength and stable molecule. If a bone angles deviate from the ideal, then the ring produce strain, and for the strain, it could lead to the instability about the cycloalkanes. So higher the strain, reactivity will be increases, means it is having the less stable compounds and having the higher amount of heat of combustion. So Baeyer proposed, from all the observations he have carried out, he observed that there are many cyclic compounds which are not stable due to the inability of near about the bone angle 109.5, and hence he says that he proposed a theory that any deviation of the bone angle from ideal value 109 will lead to a strain in the molecule, and higher the deviation, lesser the instability. So yeah, this is the picture of Baeyer, and he postulated it only for the cyclic compounds, and according to him, all cyclic compounds should be planar. Although in later part it gets changed. Amount of angle strain expressed in terms of deviations, which should be represented in terms of alpha. And all the deviation can be calculated by a simple formula: 109.5 degree minus angle of deviation divided by 2. That is, if you observe any cyclic compounds or the ring pattern compound, it must be a planar one. Secondly, any deviation of carbon-carbon bone angle from the ideal or tetrahedral arrangement, that is 109.4, it will be called as the angle of strain. And greater the angle of strain, it will lead to the lesser stability of the compound, and angle of deviations is all about half of 109.5 minus angle of deviation, that is the alpha. Now I'm coming to the next point, how to calculate the angle of deviations. So first step is that you have to draw the structure. Next step is you have to find a bone angle, that is the angle of deviation, which will be called as the alpha, and subtract it from the 109.5 degree, and then half it out, half the value. So for example, if I consider an example of the cyclopropane, its bone angle is near about 60 degree. So for 60 degree, it's if I minus it out from the one ideal 109, I will get it 49 degree angles. So alpha is all about 49. So when alpha is 60. And when I subtract it from 109.5, I will get 49. And half the value of it is around 24. So that means the angle of deviation is all about 24.75 or approximately 25. So that means it is highly unstable. Similarly, some compounds which have been expected to be stable, but in real practice it has been found as unstable due to the angle of strain. For another, if I consider another example of cyclobutane, which is near about bone angle is almost 90 degree, and its deviation is nearly 19.5 degrees. So that means that it is less, it is stable compared to the cyclopropane, which was found to be 25. So similarly for cyclopentane, it is nearly 1.5. That means it is a very, very less, and which cause to its stability. So cyclopropane must be a stable one. So similarly for the cyclohexanes, it is near about 11 degree. That means cyclopropentane is high stable among all the cyclic compounds, cycloalkanes compounds. So although in later part cyclohexanes is found to be the most stable, but it is having some other reasons. So some angles of strain is near about here it is. So for cyclopropane it is 60, for butane it is 90, so pentane it is 108, cyclohexane is nearly 120. So cycloheptane is almost 129 degree, and for the cyclooctane it is 139 degree. So what are the drawbacks now? It can't explain effect of angle strain in the larger ring system. They are existed and having the highest stable conformer. So what is the reasons behind it? It cannot be explained by Baeyer strain theory. Secondly, cyclopentane should be more stable than cyclohexane. According to it, it's found that cyclopentane is highly stable compared to the cyclohexane. But practically it is not. It is not, and hence it is reversed, and it is a major drawback, major setback for the Baeyer strain theory. Thirdly, the larger link systems are not possible according to the Baeyer, as they have the negative strain, but they existed and are stable. So it cannot be explained by the Baeyer. And fourthly, larger link systems are not existed in the planar form, but in Foucault to eliminate the angle strain. So which cannot be explained by the Baeyer strain theory. So for that, Sassesmore gives an strainless theory, which was that all the cyclic compounds can exist not in the planar form, but also in the strain-free Foucault conformations. For example, if I consider the cyclohexanes, they existed in the both and the CR form, and which is as shown below. So this is the CR form. It just looks like a CR. It is the twist boat, that is the boat can be twisted, and here it is the boat conformer, just look like one boat. If I go for the equations now, then some of the equations which have been earlier asked that what is the Baeyer strain theory, where it is not applicable to the cyclohexanes. So cyclohexanes cannot be applicable to the Baeyer strain theory because it was based on a wrong assumption that all cyclic compounds were planar. So cyclic compounds may not be a planar also. So that means Baeyer strain theory is not applicable. Similarly, another question is that define torsional strain. What is the torsional strain? So molecules having strain about the carbon-carbon single bond. So this arises due to the bone pair repulsions. And greater the torsional strain, there will be a lower stability of the conformations. So that is, stability of any conformation should be inversely proportional to torsional strain. Higher the torsional strain, lesser the stability, and lower If it is lower, then stability will be increases. For example, diagrammatically, if I show you one, so here it is. Here it is CH3, CH3, there is a two groups. So due to the presence of CH3, which is highly crowded, there is a steric strain as well as a torsional strain. Here between two hydrogen atom, there is a torsional strain. Here it is between two hydrogen atom, there is another strain, which is also a torsional strain. So these are all about of torsional strain. Another question so commonly asked is that the angle of strain. So angle of strain is just the deviation of ideal bone angle, that is 1099, and any deviation from the usual bone angle, that is 109, is called angle of strain. Greater the angle of strain, lower the stability. So for that, the stability of conformations is directly inversely proportional to angle of strain. And one example is that for considering an example of the cyclopropane, here it is ideal bone angle should be 109.28, which has been from dotted to the left hand side dotted one line to the right hand side dotted line, that is 109.28 days. But in real practice, in cyclopropane, that is hardly 60 degree. So if it is having 60 degree only, the angle of deviation, angle of strain is near about 24.44 days. Here it is 24, here it is another 24. So that's why it is less stable. So it is called. Thanks for the watching. All the doubts, comment below. Subscribe the channel, and whatever you will like to hear in the next video, kindly comment.